tutorial. My name is Dr. Jude Jepu. In the last video, I actually demonstrated how to use Microsoft Excel to convert the angular coordinates, that's the long lats, longitude and latitude, to decimal degrees, which is the data format that is acceptable by the GIS software. This morning, I want to try and use software that can do that automatically. Using Excel, we wanted to build our foundational knowledge on how this conversion is done. In this place, we will now see that these are the things that were done at the back end, and now we can now see it here. So it's important to know how to do this. I won't, like I said, advise you to continue using Microsoft Excel, but you can use these tools in order to fasten the process. So what we're going to do first is to go copy the data that we have separated in the last videos. These are longitude and latitude values. We copy them, Ctrl C, and we come here and paste them here. Paste. So what we're going to be doing is to convert this to decimal degrees first, and then to other formats. First of all, I'm using Rockworks 16 to do this. So we'll go to coordinates, we'll go to multiple points. Now, as it shows, so we want a situation whereby we map these coordinates to different colors. Like we will notice that the longitude is in column 1, longitude degrees in column 1, the minutes is in column 2, and the seconds is in column 3. Same thing for the latitude. The latitude is in column 5 degrees. Column 6 has the latitude in minutes, and this is in seconds. So we will now convert it. So for the conversion to happen, we have to accurately map these various data to their various columns. So we want our data, the input of the data is degrees, minutes, and seconds in separate columns, and we have it at 1, 2, 3 for the longitude. We have it correctly mapped here, and 5, 6, 7 for the latitude. So if it's not correctly mapped, you can drop down this arrow and choose the right mapping. So as it were, we have done this. So how do we want the output to be? We want our output to be decimal degrees. Of course, we can do some other ones which we'll demonstrate shortly, but we now need it in decimal degrees here. So let us map it to columns 8 and columns 10, just to separate them so that we can visualize these values. Of course, it can be in any of these columns, however you choose to have them. So we have this here. So we have this in the column 10, 8, and 10. So what we are going to do is, now that we have this, so we can now copy these values, Ctrl C, open your Excel. We have, okay, let's make a new workbook, and this is our X, and we now paste these values here. So this is X, we are coming with the Y. So we go back here and go and copy this. We copy this and paste it in this place. So that we have X and Y here, and this is the DD. So let's do same and convert it to UTM. So this is using Rockworks to do this process. So we'll go back to coordinates and we'll go back to converting to multiple. We have multiple points that we want to deal with here. So in this case, this input is still correct, but then we need it in UTM. Now it's important to make sure that okay, let's map this to maybe 12 and 14, as it were. So our datum is WGS 84, but our zone here, we have to convert it to zone 32. Suffice it to say that zone 31 extends between 0 degrees longitude and 6 degrees longitude, while zone 32 starts from 6 degrees to 12 degrees. So any of these UTM zones, I'm going to make a separate lecture on how to understand these different zonations. So we choose zone 32 and we click on OK. Now it brings our results here that we can copy and then use, because these are the two data formats that can be used in the GIS software. So we come to this place, we make another worksheet, name this X, we name this Y, and this is our X. We go back here and we do this and copy. We have to paste it here for our Y. Okay, so we have this now, and this is our UTM. So whenever we want to import it into our Excel, our mapping program, we'll know what to do. But meanwhile, let us save this as a CSV, because most times it's better you save these things as CSV. So we have our coordinates, as it were, coordinates in CSV. We'll go and use this CSV comma delimited CSV, the coordinates. So we save it here. Yes, we can accept yes. Let's get yes here. So there are several other things we can do using the Rockworks, and that is, if we come here, we can still do coordinates here. We can do this. So we can have this, we can still convert them to have all these columns, single columns annotated, just like we did using the Microsoft Excel. So let us map it to 16 and 18, for example. Let's say okay. So what we see here is that it has done this annotation like we demonstrated using Microsoft Excel. Like I said, all these things can be done automatically using this software. It makes the process very fast, and that's all we can demonstrate. But let's see something again that we can do here. Here we can do this, convert to single single point. So you can do a lot of things. You can put the long lat here in decimal degrees. You can have it in decimal degrees, minutes and seconds. You can have this in degrees, minutes and seconds. So you can actually choose the different this thing here. You can put whatever you so desire and have it converted automatically. So in this case, we have it in decimal degrees here, degrees, minutes and seconds. You can choose different formats if you have your data in UTM, but this particular thing is done only for 1 point. So the output will come out in different formats. So if you want to have them in different formats at the same time for just a point, you can use this. So this has done all this conversion for you. It has done it in decimal degrees, degrees minutes, and degrees seconds. So that's how you get it done here. So this process was demonstrated using Rockworks. So in conclusion, what we tried to do was to get our coordinates that we got from the client in degrees, minutes and seconds, converted them first to decimal degrees, then next to UTM, and we chose the datum was WGS84, and we chose zone 32 because the longitude occupied between 6 degrees and 12 degrees. Once you have the longitude between 6 and 12, you use zone 32. Once it's less between 0 and 6, you use zone 31. And that was what we did, and we came here and did the annotation too. And all this was just to demonstrate the fact that you can use Excel, which is semi-automatic, and we can use Rockworks, for example, which is automatic. Thank you for watching this video.